Well, in this video, we're going to continue with some terminology of functions. If an equation in x and y gives exactly one value of y for each value of x, then y is a function of x. Next, we see that we typically use letters to represent functions. Here, F, G, H, capital F, capital G, capital H. I frequently use those letters, but you can literally use any letter you want to. And this is read F of x, G of x, H of x, capital F of x, capital G of x, capital H of x. Let's look at a function where we used a little f of x. F of x is equal to 3x squared plus x minus 2. That's a function. What is the function value, that's what we're defining, at x equals 10? Basically, that means tell me what the y value is if x is equal to 10. Another way of thinking of it is if you input a 10 into this function, what is the output or value of the function? So all we need to do is find f of 10. F of 10. The x is 10. So you replace that x with 10, and you replace that x with a 10, and you replace that x with a 10 as well. So we would get 3 times 10 squared plus 10 minus 2. And that looks like it'd be 100 times 3, 300, plus a 10 is 310, minus 2 is 308. F of 10 is 308. So one ordered pair of this function is the xy pair 10, comma, 308. That's one, just one ordered pair. So the 10 is considered the input and the 308 is considered the output. This is part of the domain, this is part of the range. Now evaluating functions that one was easy. We plugged a 10 into the function and we figured out that we got a 308. Well, let's do the same thing, only this time we're not going to use only numbers to plug in for the x value. Well, in this case, we need to find, given this function, g of x is x squared plus 3x plus 5, find g of 2. Well, I didn't give myself too much room, so I'm going to start over here. G of 2, if I replace x with 2, I'm going to have to replace all of these x's with 2, or both of those x's. So 2 squared plus 3 times 2 plus 5. So that's equal to 4 plus 6 plus 5, or 15. So g of 2 is 15. If you wanted to make a note of the ordered pair that corresponds to one of the ordered pairs with this function, it would be, I'll write it up here, 215. Now the others I'm not going to do that because we're not plugging in numbers. We're plugging in variables or variable expressions. So this is g of z plus 1. So let me again, give myself some room here. G of z plus 1. Well, I replaced x with z plus 1, so I need to replace these two x's with z plus 1 in parentheses. Z plus 1 squared plus 3 times z plus 1 plus 5. Now, I would expect you to simplify this. I'm not going to do it only because I didn't give myself enough room, but you should for good practice. So you'd FOIL out the z plus 1, and that would be what? Z squared plus 2z plus 1 plus 3z plus 3 when you distribute plus 5. And then combine like terms and you would be done. So really, this just gave us a new function. So let's look at the next one. This one sometimes confuses students because it has an x in it. Well, we're going to do exactly the same thing. We're going to say g of x plus 3, this is our given function. I'm going to replace this x with what? X plus 3 in parentheses. Do it here and do it here. So it's going to be, instead of x squared, it's going to be x plus 3 in parentheses squared, plus 3 times x plus 3 plus 5. And I'm going to let you simplify this. Maybe I'll take it out one step. That would be x squared plus 6x plus 9. Just foiling this out. And then distributing here 3x plus 9 plus 5. So that would be, if we combine all the like terms, I get an x squared. How many x's do I have? I've got 3 there, I've got 6 there. So that's 9x. Plus 9x. And then the numbers, I add up 9, and I've got a 9, that's 18, plus 5 is 23. So this is g of x plus 3. All we did is evaluate this function at x plus 3. So we replaced that x, and that x with x plus 3. And we got this function. All right. Last one, g of negative x. All we need to do is replace x with negative x. Negative x in parentheses squared plus 3 times negative x plus 5. And if we simplified that, it's really easy. What is negative x if you square it? Well, the negative becomes a positive. This is negative x times negative x. So that's just x squared. The two negatives cancel out. Minus 3x plus 5. So look how close this is to what we started with. When you replace x with a negative x here, you get x squared minus 3x plus 5. That's the only difference. Because remember, when you square an x, whether it's positive or negative, whether you put a positive or a negative sign in front of it, you're going to get the same result because you're squaring it. Okay, well, a definition, the graph of a function is a graph of its ordered pairs. So, let's do a graph, real simple graph. First, let's graph this. Well, how do we get ordered pairs? Well, we're not going to make them up, but we are going to make up the x value and then figure out what the y value is. And in case I don't think I've mentioned this, we think of f of x as being the y value. We take x, some number for x. Actually, let's just do it right now. Let's note, what is f of 0? If I plug in a 0, I get 1/2 times 0. 0, 0. So that means that gives us one ordered pair, 0, 0. Let's get another ordered pair. Choose a different number for x. I'm not going to pick 1 because I'd get a fraction. How about if we pick x equals 2? F of 2 is equal to 1/2 times 2, which is 1. So the x value is 2, the y value is 1. So I'm going to plot both of these. I know this is a straight line. We'll talk about that more later, but all I need is 2 points here. So to graph f, I'm going to put, that is the origin, which is 0, 0, and the other point, 2, 1. I don't have graph paper here. I'll do make it as clear as I can. I went to the right 2 and up 1. So connect those like that. That is the function f. I'll even write it right there. Now, notice the function g. G is very similar. It starts off with 1/2 x. And then all you're doing is adding 1. And what is this? This is the y value, right? You plug in your value of x, and after you plug it in and simplify this, that gives you the y value. Because we say y equals f of x y equals g of x in this case. So I can almost do this without really plugging them in. This just tells me, and we'll learn more about this later, it's going to be exactly the same value of f with 1 added to it for the y value. So g of 0 is equal to 1. F of 0 is 0, g of 0 is 1. So if x is a 0, y is a 1. If f of 2 is 1, g of 2 is going to be 2, because it's just 1 more than f of x. So 2, 2. And let's verify that. If you plug in a 0, well, that term goes away and you just get a 1. 0, 1. If you plug in a 2 for x, you get 1/2 times 2, which is 1, plus 1, which is 2. So if when you plug in a 2, you get out a 2. Input 0, output 1. Input, well, let's graph that. 0, 1. Right there. And then 2, 2. Okay, so basically the point of this was, and again, we'll talk more about this later, I just wanted to show you that when you just add 1 to the right-hand side of the function, these two would be identical if I weren't adding the 1 there. This just changes only the height of the function. The y values, I sometimes refer to the height of a function. I refer to it as the distance from the x-axis to the graph, just like that. The height of the function, the height of this purple function, I don't know if you can tell the difference between those colors, the height of this function g at x equals 0 is 1. 0, 1. The height of the function g at x equals 2 is 1, 2.